here we're given a series written out in its first so many terms and even an nth term formula here. And what we're asked is to find a formula for the nth partial sum. And then we're asked if the series diverges or converges. Well, we just as easily could think about this as the sum from 1 to infinity of this nth term formula. And we could add these numbers together and write out the first few terms in the sequence of partial sums, but I want to approach this one a little bit differently. What I want to do is rewrite this nth term formula to see if it helps me establish this nth term formula. And the reason I'm thinking to do this is because the last time we saw a rational function in this format, we learned about a way to rewrite it using partial fraction decomposition. So I want to rewrite this using partial fractions. Multiplying both sides by n times n plus 1, I get an plus a, right, because the n's cancel and I can go on and distribute, plus bn. All right, so looking at that, a plus b would have to equal 0, right, because I have a plus b times n and no n's over here. And then a is equal to 5. All right, well, pretty quickly then, b has to be minus 5. And I have another way of thinking about this series. All right, so let's write out the first so many terms in this series like this, right? I used to have a 5 over 1 times 2, and now I want to see what it looks like when I think about it like this. And so now the first term of this series, well, that would be 5 over 1 minus 5 over 2. Well, that is the same thing as 5 over 2, right? So I get the same thing I got before. The next term up, now I plug in a 2. I get 5 halves minus 5 thirds, which is 5 sixths, right? And so term by term, I'm getting the same thing, and I feel good about that. We would just continue that process. 3 is in now, and I get 5 thirds minus 5 fourths, plus dot, dot, dot. And let's just imagine I got to the n minus first term. So I would get 5 over n minus 1 minus the next term, 5 over n. And then the nth term would be 5 over n minus 5 over n plus 1. And we should go on forever and ever just like that. Looking at this will help me establish the nth term formula for the sequence of partial sums, S sub n. And the really cool thing that's going on is this one ends at a minus 5 halves and the next term begins at a positive 5 halves and they cancel. And in fact, they all cancel. The next term would start at 5 fourths until I get to that last spot. And so I have the original 5 minus 5 over n plus 1. If you add the first two terms together, you'd plug a 2 and you get 5 minus 5 thirds, and that's the second partial sum, excuse me. And you keep going out and you're always getting that. This series then converges to the limit of the sequence of partial sums, which is 5. This series converges to the number 5.